Good morning, good afternoon, good evening. Welcome to the Catalyst of Change Advancing Equity and Inclusion in Science webinar series. This series celebrates individuals and organizations driving real progress toward equity and inclusion in science. We spotlight diverse leaders, change makers, and allies who amplify the voices of women, unrepresented regions, and ethnicities, differently able people, indigenous communities, and others often unheard in agricultural science and development. Equity and inclusion in the leadership are essential for building effective, ethical, and future-ready organizations. By highlighting diverse leaders who put equity and inclusion at the center of the leadership, we aim to provide role models and improve our own institutional leadership. Inclusive leaders bring people with different experiences and worldviews into decisions making, which results in more innovative solutions, greater ability to anticipate risk and unintended consequences, and better representation of stakeholder needs. Our catalyst of change today is Diana Horvath, co-founder and president of Two Blades. Diana Horvath previously worked as science director at ATP Capital, a New York venture capital firm investing in agriculture biotechnologies. Focusing on technology and intellectual property, she helped to build and manage a portfolio of companies involved in forestry biotechnology, transcriptome, and proteome analysis, small molecule discovery, and embryonic stem cells. As a postdoc, Diane was a fellow of the National Science Foundation and Seneca Plant Science at Rockefeller University. Diana earned her PhD in biochemistry and molecular biology from Northwest University and conducted research in Botswana on maize and millet production, an experience that shaped her commitment to making science impactful in the field. Diana Horvath will have a conversation with Shukai Zhang, a senior scientist and maize molecular breeder at CIMMYT headquarters. Since joining CIMMYT in 2011, Shukai has led efforts to implement modern molecular breeding tools to accelerate genetics gains in maize breeding programs across Latin America. Since 2024, he has coordinated maize collaborations between CIMMYT and China. Now, without further ado, please welcome to this Catalyst of Change, Diana Horvath.
Good morning and good afternoon and good evening, wherever people may be. Thank you so much for inviting me to this wonderful series. It's really very important to have this emphasis on the human capital portion of this effort that I know we all care about, trying to bring solutions for agriculture and emphasizing different ways to approach that and the human capital side. Today, I will share my path to my role today as president of Two Blades, where three big moments occurred where I departed from sort of a conventional path and how those made a difference for me, and four main challenges that I encountered along the way and some of the lessons that I learned. From early on, I had an interest in science. I grew up in New York State in an area that was a lot of beautiful nature and agriculture, and I had an interest in gardening and food, and also science. My parents encouraged an interest in science. So from early on, I pursued a fairly conventional path of trying to learn science in school, and as an undergraduate studied biology at Tufts University. And one thing happened there was that at that time the hot new field was molecular biology. And I was fascinated by this. I took some introductory courses. I understood about genes and genetic control, and this was really fascinating. There were companies coming out that were doing amazing new things in agriculture, like creating artificial seed, and I was fascinated, and I wanted to go to grad school to study this some more. But unfortunately, I managed to miss the appropriate time to apply to grad school in the fall of my senior year. And I don't know how I missed this. It was stupid and unfortunate, but ultimately it proved fortunate. Another thing that happened as an undergraduate was that I became best friends with a woman from Botswana. And at the end of my undergraduate time, she invited me to come and visit her in Botswana. And so I planned a 2-week holiday to do that after graduation. For various reasons, 2 weeks turned into 4 weeks, and then 4 weeks turned into an idea. And this was my first big unconventional decision and big moment in my life, was to stay in Botswana and work in agriculture and apply to graduate school from there in the next fall. And so I did this. I worked for the Department of Agricultural Research in Botswana, their research station. And this was a huge change in my life and unexpected and very, very powerful. At that time, I stayed and worked on 2 projects. I worked to apply some knowledge that I had developed as an undergraduate about mycorrhizae. So I looked into the potential for mycorrhizae to improve sorghum cultivation. And I also worked on a project for the UK that was looking at 3 striga species, witchweeds, that affected corn, wheat, and legumes. And so in this process of doing field biology and looking at these research topics, I was exposed to a lot of new information that I didn't know about agriculture outside of the US, how challenging agriculture was there, the low fertility in soils in Botswana, the high temperatures. We had soil temperatures of 55 degrees C at times of the year, the challenges in growing crops, insects, weeds, and of course, low incomes. And this was a real eye-opener for me, and of course stood in contrast to what I was familiar with in the US, where we had so many resources and tools. And it really struck with me that if we could just ensure that even small amounts of these could be made accessible in developing agriculture, what a meaningful difference that could have in people's lives. And even though that I couldn't do much at that point, I knew that coming back and studying molecular biology was a really interesting way to think about addressing this problem. And it was these 2 things coming together at that time that really influenced what I wanted to do and go on to do in my career. So the notion of using all of that high technology from molecular biology and put it into a low technology format of the seed, that was something that farmers anywhere could use without a lot of extra equipment or skills or knowledge. So I was hooked, and not only did I think that there's the potential for molecular biology to have meaningful application, but there was also this notion of equity. How do you get it to smallholder farmers who need it most? And as an upside, I think spending the time in Botswana also helped my application to grad school. When I finally did get around to it, it was a little bit unconventional and helped me stand out. So that was an unexpected benefit. So I came back and I continued my conventional education. I went to grad school and did a postdoc. And I was driven in both of those by really an interest in application and impact. And so as I went through my process of education, when it came to the end of my postdoc, I was really looking for opportunities that had impact. And even though I applied for a couple of standard academic jobs, I also applied to companies. And I really was not so interested in the academic path, which my husband was. And this seemed almost like a good idea. We would have our own areas. As I was trying to figure this out, an opportunity happened to come to me, which was a venture capital was looking for a scientist, a molecular scientist, to help them vet the science in companies that they were thinking of investing in. And these were all scientific companies developing agricultural biotechnologies. And the founders of this fund had success with the first GM crop, and this was insect resistance cotton. They had developed BT cotton. This was at the Delta Pine Land Company, which was sold to Monsanto and was very successful. And they had earned a good amount of money in that and wanted to replicate the success of that. For me, with my background and interest, this was perfect. It was so exciting. So I took a chance to think about this opportunity. And the question that I had at the time was, there was no path. I didn't know anyone else who had gone into a venture capital kind of position. And I wondered, if I stepped off the academic path, what job opportunities would I have if this didn't work out, or where did I go from there? So I thought about it, and I made the second big decision, unconventional choice of my career, which was to try it, to take a year, give it a chance, see what I would learn, and if it didn't work out, I'd do something else. And so I did, and I started working in venture capital. I loved it, and I worked there for more than 5 years. It was a very exciting time where different science ideas were brought to us to be considered for investment and being tested as a business. And it was really the opportunity to see how science could deliver impact in a commercial setting, which is very different when you're at the bench and thinking about what can you do scientifically, what questions can you answer, what can you learn about nature or biology. So this really helped me in many ways to think about science in a different way and learn to think about other related things like intellectual property and what it takes to deliver science. And the impact of markets and all the business side of it. And even though my role was focused on the science aspect and doing the diligence in the companies, I had to see that through a business lens. And that was very, very informative. And towards the end of my time at Agricultural Technology Partners, I had an offer from one of the people associated with the fund who was a science advisor, Roger Friedman. And Roger had spent his career advising David Sainsbury in the UK and his Gatsby Foundation to create science institutions in the UK, the Sainsbury Laboratory in Norwich. And in the process of that work, Roger became aware that there was a gap from discovery to deployment. And how could we ensure that all of the good science that was coming out do something useful in society that could benefit agriculture and have real impact in the field? And so he wanted to address this by establishing a different type of organization, because fundamental research was important and focused on discovery. And there was not a great process for those discoveries then to be put into practical use. It's a lot of reduction to practice work. It's not the kind of thing that gets publications or aligns with academic interests. And it was very early stage for commercial interests to get involved and to know if there was something there that could be useful in a commercial setting. So we needed something in between. And so we decided, well, Roger's idea was to set up a new model, experiment with a new model of an organization that did just this sort of reduction to practice translational research work, and do it as a nonprofit. And in that nonprofit mode, we could not only take the time it would need without being so concerned about a company making a return on investment, and we could have a dual purpose, which was to have the science not only benefit commercial agriculture, but to ensure that it could benefit smallholder agriculture too. And for me, this was really the moment where all of my interests came together, the science and the business and the equity portion of science. And so I was very interested. And then again, I had to consider the question of, well, if I do this, what other options will I have going forward? And again, I made the decision that try it for a year, see what happens. It's not a permanent decision, and we can see where it goes. And so I made my third big decision of my career, which was to help start Two Blades. And I've It's now been 22 years since we undertook that experiment, and that's proved to be an exciting and successful model that we still are working to advance today. So in the process of these big decisions, of course, there's day-to-day challenges that everyone has for managing their personal life, and I raised 2 kids, and all of that going on together with the challenges of making these leaps of faith into doing different things in my path where I really had no experience. And these were essentially 4 situations that I had to figure out. What it was like to work in business, which was different than working in science, different kind of lens of how you conduct science. Starting a business, and this was really a lot of new skills that I did not have, things to do with legal aspects, human resources, and so on, accounting, all kinds of fun things. And although I had help for those things, I still had to have an understanding and mastery of them. How to deal with conflict. There were times where the ideas of what should happen and who should do them presented real interpersonal challenges, and I had to come to learn how to manage those. And then for me, the 4th situation was really how to take on a mantle of leadership ultimately. As a baby of my family growing up, I was used to not having the loudest voice in the family and was accustomed to deferring to a lot of people in the process of my career. So how to find my own voice was definitely something I had to figure out. So even though these situations were different, in all of them I had to essentially level up my skills so that I could have tools and a path to move forward and address these challenges and deliver on the things that I was trying to do. So in order to make that happen, it was very helpful, I found, to keep an open mindset, to have a curiosity about learning and growth, and being open to trying new things. A lot of that was on the job learning. In the course of my time, there weren't a lot of courses or training that were available to me, so figuring it out on the job was something that happened, and I'd say there's nothing like having reality better than theory to help you sharpen your skills and what you're trying to do. One of the biggest things was having trusted advisors to help along the way. And though there are very few female mentors out there in science and in agriculture, at least in my experience, there were other people along the way, men who were very helpful in giving me the direction and the feedback that I needed to take on the tasks that I was trying to do. And so those have become lifelong friends as well. Having support in your personal life is also very important. And then even coaching has been something that's been incredibly helpful for me over time, where really have somebody who is an expert in a certain area guide in certain skill sets like communication. And then probably one of the most challenging areas, most elusive, was finding my own voice and getting comfortable with putting my own ideas out there. And it does take a certain amount of confidence and trust in yourself to learn how to do that. And this can be in the face of people who tell you that your ideas are bad and that you don't know what you're doing. But here's the secret: no one really knows if what they're doing is the right thing. We're all doing experiments, and realizing that helped me to understand and appreciate that if you've done the work for the thing that you're trying to do, then you just need to trust yourself. And why would you let someone else define who you are? And in the process, I learned that even though there are so many challenges, that at heart, I am an optimist. And even though I'm aware of plenty of potential pitfalls, especially in this work of solving agricultural problems, I really care about it, and I'm willing to keep going in spite of those. So thinking about those challenges and the process along the way, I learned a few lessons. For starters, those unconventional opportunities, those were the best. Those were the opportunities for the greatest learning and growth, both about myself and how to work with others. And they really provided me the greatest joy and excitement in my career path. And the challenges that came up at the time, they may have been painful and uncomfortable, but ultimately these are the things that make you more knowledgeable and strong, and you come out better in the end. I learned that solving agricultural problems is really, really hard and slow. It takes a huge effort, and you really have to be committed. And it's really important to find other people who share in that commitment and help lighten the load and help move it forward. Good supporters is really key, as I mentioned, good colleagues. And it's one thing if you surround yourself with good colleagues, you can't just let them go and do their work. They need other things. So for example, I've learned that you really need to have a clear and compelling vision to share with people and communicate that well. Communication is just so important. And building a culture that enables people to achieve is very, very important. And one of the core elements of that is having an environment where you can give and receive honest feedback in a caring way, and to present people with opportunities to grow. And I found that in my own path, that the times when I've been very open and vulnerable about the struggles that I've had trying to learn different areas are the opportunities that have created allies and people invested in helping me and really build trust. So I'll stop there and hope that captures some of the issues and situations that I encountered along my way. And I hope maybe presents a few opportunities for other people to reflect in their own journey about how you can not necessarily have a straightforward plan or a path to think of how you get there, but if you have an understanding of the things that are meaningful to you, that when certain opportunities come along, you know that those are the opportunities to say yes to, even if they may be quite different than what you expected or unconventional. So thank you.
Dr. Chukai, please go ahead. Sorry, your micro is off, Dr. Chukai. Okay, very good.
Okay, yeah. Thanks for sharing your experience, Diana, and good morning. It's my honor to talk with you and also to share your experience with the CIMMYT colleagues globally. You have a very unique career path, yeah, from the fundamental research to the venture capital firm, and then to co-founding your company. You already mentioned that it's lots of your experience, how that motivates you to do the research, and then from the fundamental research, and then to the company, and then to build your own company. So I would like to ask you to provide to share with us a specific moment or discovery, what motivated you to do this kind of change. Because for me, after my PhD study, I keep working at CIMMYT. I don't have this kind of experience. And then I would like to know which kind of motivation help you to want to make this change. And then this kind of experience may also help you, our young scientists, to think about their long career development. Yeah, thank you.
Thank you so much. Yes, well, I would say that for me, there was not a really specific defining moment, or it might have been one that came later, but it was certainly the combination of experiences that I had, especially in working in developing agriculture. And I mentioned the meager yields and the enormous challenges to agriculture, and living through that personally really left a big impact. I could really see the struggle to produce adequately and knowing that there were better tools available. But I also felt that I experienced hope working on a research station, and a lot of a community of people dedicated to this problem, both local participants and international staff. I got to visit ICRISAT in Zimbabwe, and that was another really great experience, seeing how research was leading to improvements in agriculture. And if maybe it crystallized in a single moment, it might have been when I came back to the US after living in Botswana, and really pretty soon after, I had to go to a local grocery store. And I vividly remember stopping in front of the ketchup aisle and looking that there were so many types of ketchup, shelves and shelves of ketchup. And it actually made me mad in the moment. I thought, how ridiculous. We have so much choice and so much opportunity, and that's just not the case in other places. There's real scarcity, and that kind of really drove the point home for me.
Yeah, that's very great. Yeah. So, yeah, I think CIMMYT and your company, actually, we share the same mission. Yeah, I checked on that information on your website. So we would like to deliver some affordable products to the farmers, yes, through the new tools and the technology. So yeah, from the company website, I found that also you are working on a project to develop the trait that can enhance resistance to mycotoxin. Meanwhile, I'm also working at CIMMYT, working on ear root resistance, which actually is a major disease in maize and then to cause the mycotoxin. So yeah, but based on my research experience, the mycotoxin or the ear root resistance in maize is a very complex trait. I think it's very, yeah, as you mentioned that, it's very difficult to solve this kind of problem in agriculture. So yeah, fortunately, we have some new tools like the AI tools to discover the genes, and also we have some big data tools like the genomic selection to improve the complex traits, and also we have some new biology tools and then to discover the genes and also to deploy that one and then to build the DNA into the seed. Yeah, so I would like to hear from you, yeah, how the conventional breeding team, the molecular breeding team, and also the biotechnology team can work together and then systematically to solve this kind of problem using the different, yeah, cut-aging tools or technology. Yeah, what's your idea or what's your suggestion to work together as a team and then to use the different tools to solve the difficulty?
Yeah, it's a great question. Thank you. I think this is actually a key moment for scaling molecular tools. Whether it's with conventional breeding, there are ways to make it more efficient and more productive, or dialing in different biotech techniques. And there are some problems which are very difficult to solve by conventional breeding. And I think that's where you have a continuum of things that you can do with conventional breeding and should do, because you don't need to invoke more complicated technologies if you have a straightforward way of solving the problem. And we've always tried to make that distinction that for us, we tend to focus on the really intractable kinds of problems that can't be easily solved by conventional breeding or crop protection approaches or integrated pest management, but things where we want to reach for deeper tools. But I think going back to your point, how we kind of go from one to the other or complement each other is really critical. And it's, as you mentioned, our maize program, we know that CIMMYT and others have ongoing efforts to try to address this really critical problem of fungal infections that produce mycotoxins, because it's a double whammy. Not only does it affect yields, and that creates losses, but it has all those health implications for people and for livestock. And so it's both an agricultural problem, but also a public health issue. So it's doubly important from that perspective. So for us, we had a few tools that we had developed. We call a platform of gene discovery tools that we've put together BladeSeq. And in BladeSeq, we have some ways to discover different immune molecules from plants. So the intracellular receptors, the NLRs, as well as the cell surface receptors, the PRRs, and on a kind of a high throughput basis. So we're deploying those tools to see, can we produce new solutions for addressing resistance to fusarium, in particular, and aspergillus, as a way to nip this problem in the bud early on. So trying to protect the crop itself from the yield losses, and also the human and livestock health that comes from the mycotoxins that they produce. Now, we definitely see this as a partnership with other efforts, and where conventional breeding and using genomic selection tools can be used, we not only applaud, but we actively support that. So we have a program with IITA where we're doing just that, looking at soybean rust resistance in soybean. And that's an example where the soybean global germplasm has very limited number of resistance genes in them to Asian soybean rust, which is currently the biggest disease issue affecting soybean. And IITA is very invested in soybean. It's a very promising crop, especially in Africa, to create not only income for growers, but also human food and livestock feed. So it's been a prioritized crop, but it's not going to be able to fully reach its potential without a solution for soybean rust. So we've been working very closely with soybean breeders within IITA to help support some of those molecular breeding approaches. We have some capability in our labs in the UK and in the US that we're trying to leverage to support them, while also thinking about how do we combine genes to make durable and long-lasting resistance to soybean rust. So these are just, and as a third example, we've also supported and worked with the International Potato Center with their program on late blight resistance in potatoes. And that's a full-up GM approach. They've taken 3 genes and stacked them, made a molecular stack, and put those in local varieties. So we see in each instance there are different ways to try to thwart the problem, and we're trying to support those where it makes the most sense.
Okay, yeah, thanks. You mentioned the partnership, and also you mentioned that about how the different teams can work together. I think we are both we have a common interest on the year root, and then also the year root cause mycotoxin issues. I think that's a very urgent and also the serious issue in maize production. So I think this seminar provides us a great opportunity to work together. Also, you mentioned the partnership, right, with the IT and also with the SAFE. And I'm looking forward to working together with your companies to work on the ear root resistance and also the mycotoxin issues in maize. Okay, thank you very much. And I think we will keep in touch, and then hope we can work together on this project. So actually, I really like your company's culture about having some private sector mindset, and then with a non-profit scope, and then to deliver the products to the commercial farmers and also to the small farmers. At CIMMYT, actually, we are mainly, our target are mainly focused on serve the small farmers, and then. So could you tell us something about this, how to serve, how our work can benefit both the commercial farmers and then the small farmers? What's the difference? Then how we can do better to serve the different clans?
Yes. This is where we try to deliver a kind of unique value, is by, maybe to step back to say that these challenges are great, and certainly Two Blades is not in a position to do it alone. We have defined the whole framework of bringing innovation to the market as an agri-food innovation chain. And we think of ourselves as part of that process. And the way we think about that, and it's useful for us to think about how we achieve the goal. So there are certain direct sort of events that have to happen, from a conception of an idea to validating it, to deploying it, to achieving impact, and how you get feedback from the market to that. That's one part of it, but there's also a whole enabling environment that has to be there to make sure that all of these things can happen, and whether that's funding or policy or communication, all of those things have to be part of it. And so we know that we are just a piece in the middle. And so we really rely on those partnerships and building those partnerships so that we have the confidence and we can create efficiencies for bringing those innovations into practical outcomes. So the idea of partnering is very important to us. And the way we've tried to do it a little bit differently is by leveraging what we do in a commercial setting to also enable smallholders. And we do that in a couple of ways. So we will take projects that we do directly with commercial agriculture around a problem. And here's an example that I've just mentioned, soybean rust, which is a great example in this case. So we've worked with two companies, Corteva and Bayer Crop Science, to discover new sources of resistance to soybean rust. And we've put those into their product pipelines. And this can have the potential of commercial benefit, so helping soybean growers at large scale, and that definitely fits with our mission. It gives us the opportunity to improve our skills and build resources and create new options for tackling this particular problem in this case. And we have a reservation of rights when we work in those projects, that genes that we discover, we retain rights to give those away on behalf of smallholders, or to very small seed companies working on behalf of smallholders. And not only that, that enables us to extract value from those partnerships. We also get in-kind support often with companies who want to help, but they don't have the resource to invest in it directly. But working with us in partnership fills a mission for them as well. Their scientists really want to see global impact. And then the third part is doing it in this way enables us to earn to cover the research, but also as a nonprofit, we are entitled to some fair market value, to the value that's created in the commercial setting. So we get some revenues back on that, and that income helps us to sustain the work that we do, where we're not going to make money, that we want to make it accessible for smallholders. So it's one way that we've come up with for making sure that we can span that and use science in a sort of a common core way to have these dual benefits.
Yeah, thanks for sharing your comments and also your ideas and how to serve the commercial farmers and also the small farmers. Following up on these questions, also I would like to ask you about what do you think is the biggest bottleneck for the technology transfer? Yeah, because at CIMMYT also we always mention that we would like to do some basic research and then on the discovery work, and then but our final product will be our technology or our hybrids, and then we would like to provide the seed and then the technology to the farmer. But we have to think about the whole picture, right? From the discovery work to deployment work, and then to promote promotion of the technology and the seed to the farmers. So from your perspective, and then what are the biggest bottleneck from the discovery work and then to final products, promotion of the final products to the farmer? Is the research and the development itself, or it's like a policy issues or the IP issues, or any suggestion or comments from you?
Yes, it really ties to this description I was just giving of this agri-food innovation chain as we, kind of the system map for all of this. And where are the bottlenecks, as you say? And I would, depending on the kinds of products you're trying to produce, I would say the whole system is anemic and fragmented. And that's really the biggest problem, that ag and plant science research is underfunded. In the US even, we're at the same funding level as in the 1970s, let alone international agriculture. And we're all unfortunately very familiar with the fact that in the current environment, the available funding for international agriculture has dropped down considerably, and a lot of countries are withdrawing from international funding, and that really adds to the challenge. So the system as a result is quite weak, and it's the fragmentation that I think is a great barrier to getting things done. How do you find the partners you need to put together the path, and how do you make that more efficient and functional? I think that's a major focus for trying to strengthen the system, and we think about that a lot. I'd say if you are going for biotechnology, as we are, you have another major barrier, which is the regulatory process. And this creates, especially for GM crops, enormous costs and time frame. We know that research itself is pretty slow to begin with. You have a lot of testing, biology is hard. Some of these problems that we're addressing is very challenging, and it does take time. And I'd say this is a reason why we really need to emphasize and communicate having all the tools in the tool chest is so important, because of the overall time that it takes to deliver new innovation. And we need to be open to tools that can speed that up, or partnerships that can help speed that up.
Yeah, thanks for mentioning the partnership and also the funding issues, and then also the fragile environment in agriculture. I share the same feeling, and also I think that's the topic or the theme of this seminar. And then we would like to encourage the young scientists to motivate them and then to work on agriculture. But meanwhile, also we would like to inspire them and then to working to develop some of the leadership skills. I think that's the main purpose of this seminar, to highlight the role models like you, and then how you can you put the equity and then also the inclusion in the center of your leadership in your company. And today I think we have close to 60 people. I guess mainly are the young scientists who participate in this seminar. And then thanks you to provide us a great opportunity to interact with our young scientists. And then so in order to improve our own institutional leadership of CIMMYT, and then my final questions, I would like to ask you about your future outlook or the advice for the next generation young scientists. So what do you think is the next great challenge in agricultural science? Is the leadership or is the technology itself? And then what's your suggestion or the recommendations to the young scientists, and then who can contribute to our CIMMYT, our mission, right? Not only CIMMYT, as well as the to build your company, because we share the same mission, and then to deliver, to do the discovery work, and then deliver our products to the farmers. So at the end, we would like to ask you to share more experience, and then to your message, and then to share with our young scientists about the future look, and then for the next generation, we call the breeders. Okay.
Yes, and this is such an important question, because the future is for the youth, and having them well prepared and motivated to take on some of these challenges is crucial to solving them. I would say that I have 6 thoughts of things that I would really like to see happen in agriculture, and where young people can find opportunities maybe to push on some of these things, I think that can help move the needle. And so my list is this. So firstly, funding. That could be the top 5 items in the list, but I'll just make it one. As I say, that the whole enterprise of science is underfunded, and how we get people advocating for funding and helping to understand the need. I think this is a communication part that scientists can do to help, especially to communicate the value of science, but in human terms. And I think this is something that we struggle with as scientists, because we think about the technical, we think about the how we do it, and we need to talk more about the why it's important, so that people who are not scientists can understand why it's important. And in this way, how we can influence and advocate for more funding for so many aspects. And this, as I say, is a whole framework that's needed. There's infrastructure. So this would be a second one, is how we have growth in agricultural infrastructure. And by that, I'm referring to facilities, seed systems, policy environment, how we train people adequately around the globe, and how we develop regional bioeconomies and create jobs so that people can get training and then they can find a place to work and contribute. How we do that is really important. We need to think really with that market mindset as well. A lot of agricultural research and development has been funded by funding agencies and donors, and it's often a project kind of mindset that, you know, you have 5 years to accomplish X goals, where I think we need to have more of the emphasis on what's going to create value in a marketplace for a consumer or a grower or whomever, because they're ultimately going to pay for that. And that will help make the system more sustainable and really deliver real world values. So that's 3. I would like to see more female mentors and role models and more women in leadership roles, more diversity there. The focus of this series is so good to bring diverse skills in leadership. I think that's very important. 5th, I am encouraged by the trend of the use of molecular tools in conventional breeding, as well as the opportunities for biotechnology. And I think that that's a trend that's growing. You see more and more countries adopting biosafety frameworks, and I do feel optimistic that that's going to continue to improve, and we can bring forward those conventional products as well as new and improved products using gene editing or transgenic technologies. And then the 6th item that I'll say, that we all as scientists need to fight misinformation and disinformation. That if we want to have acceptance of science and let science lead the way, we need to put the general public at ease about science. And again, coming back to those stories and why science is important, what benefits it can be achieved. I was just at a conference last month about the impact of mis and disinformation on science, and especially in places where science is needed most, parts of Africa. When you deny those benefits, it really impacts people's lives. So speaking out in communications is a very important role for scientists too. So I think if we can make some progress on these 6 areas, I don't think there's any one magic bullet, but we need to keep strengthening and developing this agricultural innovation chain, that's going to help us achieve the goals of solving agricultural problems.
Okay, thanks for your 6 suggestions or recommendations. Also, I learned from that. I would like to make my final comment. Yeah, I think the different people are at the different career development stage, and then but your information is very useful for the people in the different career development stage. Yeah, I also benefit from that. Then I would like to address that. I think it's no matter you are a young scientist or in your mid-career development stage, I think you have to think bigger, think farther, and also think deeper. And also, I would like to address that. I think, as you mentioned that, we need to think about our career development from the stakeholder needs, from the leadership need, and also from the impact what we want to contribute globally. Then finally, I would like to say that we are not only need the next generation breeder or scientists, but also we would like to have more next generation leaders, with great motivation to contribute to the global agriculture development. Okay, thank you again for provide us your experience and then share your experience and also your recommendations with our young scientists, which will help our center to motivate our young scientists and then to also develop our talent program. Thank you very much again.
Thank you so much.
Thank you very much, Shukai-san, for having this interesting and stimulating conversation with Diana Horvath. We invite the audience to participate in the open Q&A session. Be ready to raise your hand, open your micro and your camera. Also, you are invited to submit questions via Slido for our distinguished speaker of today. So we have received several questions already on Slido, and I'm going to read the first one. It says, what big shifts do you see happening in agriculture technology space now, such as the recent news that Corteva will separate seed and crop protection into separate companies? That will shape the future of agriculture research and development?
Well, that's a big question. And I think we'll all be interested to see how that split may impact Corteva's activities. I think it's not uncommon that companies seek to combine businesses for greater efficiencies from time to time, or to split them out to focus on specific areas. So we'll see how that might impact science. Of course, Corteva has been a big proponent in terms of seeds for gene editing approaches. And I imagine that they will continue to focus on that and the potential for delivering new traits through gene editing. So coming back in terms of the shifts in agricultural technology, I don't know if there will be major shifts in what we've talked about today, advancing conventional breeding with more molecular approaches, genomic selection and so forth, advancing gene editing or transgenics in certain places. I don't think that we will expect any radical shifts there. And of course, there's always some level of new discovery that's going on for additional approaches. RNAi has been an approach that's been tested. It has not gone prime time so far. So we'll keep watching this space and trying to find the tools that are most appropriate for different crop situations.
Thank you so much. Here we have another question. It says, for those scientists who might like to become mentors, what skills and characteristics are helpful for being a good mentor?
That's a very interesting question. And I love the notion of people wanting to mentor. I do think mentoring is just one of the key aspects for career development. And I suppose the skills that you might want to cultivate depend on how you want to mentor. I do feel like in normal science education, we get a pretty good understanding of how to conduct science. What is quality science with the right controls, how you ask the questions, how you validate it. At least in my experience, that part was straightforward. But what was missing was more on the interaction, the co-worker aspect. I think that a lot of scientists finish their laboratory part of their career and nobody's taught them, how do you write a grant? How do you oversee people in the laboratory? How do you start a company? And those are areas where mentoring would be very helpful. If you're a scientist, perhaps getting some knowledge in that and sharing that with others would be a helpful way to do it. I certainly have gotten great value from some of the mentoring that I've had, and also coaching on communications and leading teams. All of that, I think, is really just incredibly helpful. None of us really come into something with all of those skill sets, so it's really a great opportunity to avail yourself of those from others. I encourage mentorship.
Thank you so much. What advice do you have for organizations like CIMMYT who are working to promote diverse leadership? What advice would you give to truly help grow and support a new generation of leaders?
Yeah, so I guess that comes down to culture. And of course, CIMMYT is a fantastic organization that's been doing fabulous work now for a long time and really leading research and improvement in wheat and maize. I'd say culturally for any organization, how you foster people to grow and develop is really important. And I'd say within Two Blades, we're a very small organization, of course. We tend to focus on clarity and communication, really, so that it's understood well what are the goals that any one individual has in their contribution and how it aligns with the organizational goals. And then in terms of communication, creating a space that enables safe feedback. So both giving and receiving feedback in a way that's done with caring, that allows people to learn where their blind spots are and how to grow, and how to do this across remote working and distances. It's a challenge, but fostering a good culture really helps, I believe, to align people, motivate people, and commit to certain values and shared work.
Thank you so much, Diane. So we are about to close the session. So what words of wisdom could you share with the audience? That was our takeaway. You have already shared your list of areas that could be focused, but any other words of wisdom?
I guess I would just boil it down to trust your own instincts, be guided by the things that really get your curiosity going, and take some leaps of faith, try some unconventional things. Nothing's permanent. If it really doesn't work out, there's other things you can do, but in the process, you'll have a lot of learning. So I think those things have made a lot of difference for me.
Thank you so much. So on behalf of Dr. Bran Govers, Director General of CIMMYT, we thank Diana Horvath so much for sharing with us your outstanding professional and personal journey. Also, we appreciate Shukai Sang for having a great conversation with Diana. And thank you both for being catalysts of change. We thank and invite the audience to join the following Catalyst of Change Advancing Equity and Inclusion in Science seminar series in 2 weeks. Have a great day. Have a great evening. Thank you so much.
Thank you so much for the opportunity.